This is the homework assignment on page 55 from your textbook. I'm going to walk through just kind of your basic understandings of what a limit is. A lot of people have a difficult time dealing with both the graph and the explicit function, so I'm going to talk about both of them, but we'll start with number 9. It says, use the graph to find if the limit exists, if it does exist. If the limit does not exist, explain why. Alright, so we look at number 9 here. It says, the way you read this is, the limit as 4 minus x, pardon me, the limit of 4 minus x as x approaches 3. So what we're going to do is we're going to look as we move along the x-axis. As we move along the x-axis, what is the value of y approaching? So as we approach 3 from the left, so as we approach it from 1, 2, or from the other side, from the right, 5, 4, down to 3, the value of the function is approaching 1. Now, you'll notice if you go back explicitly here, if I just plug 3 into the 4 minus 3, I get my answer 1. That's going to work. That's always your first option. Do that as first time every time. So when we go over here to number 10 and it says, don't even look at the picture for a second. It says the limit of x squared plus 2 as x approaches 1. If I just plug the 1 in, then I would get 1 squared plus 2, which is 3. So the answer should be 3. Now look at the graph. As I approach, as I'm moving along the x-axis here, as x approaches 1 from the left, what's happening to the y value? It goes up, it goes down, then it goes back up, and where does it end up? At 3. As you approach from the right, it goes down to 3. Now let's look at number 11. Number 11 is a little bit different because it's piecewise. So the limit as x approaches 2, pardon me, the limit of f of x as x approaches 2, and then they give us this piecewise function right here. Now, what is f of 2? If I just plug this in, what is f of 2? Just like up here on number 9, number 10 I could plug in. Well, I don't plug it in here, I plug it in here. If when x equals 2, the value of the function is 0. Now let's look at the limit. As we approach the value, as we approach x equals 2, what value is the function approaching? Not what is it, but what is it approaching? So as we approach 2, the value of the function approaches 2 from both sides. So if I go 5, 4, 3, if I plug those values in, what's the value of my function approaching? It's approaching that open dot, which is 2. So over here, let's not look at the function up here. It says the limit as x approaches 1, but forget this for a second. As we approach 1 from the left, so as we get closer to x equals 1, what value does y get near? It gets near 3. How close does it get? As close as we want. As we approach from the right, what does it equal? It's approaching 3. Now, on these problems, compared to the problems before this, you'll notice these problems, the value of the function, which is in this case 1, is not the same as the value that it's approaching. So the limit and the value are not the same. That deals with what's called continuity or being continuous. These are not continuous because the limit doesn't equal the value. Scrolling down here. Next one, the limit as x approaches 5. Now what's of the absolute value of x minus 5 over x minus 5. Can you plug 5 in the equation? It's the first thing you always try to do. No, because we end up with a 0 on the bottom. So let's look at the graph. As we're approaching 5 from the left, as our x value is approaching 5, our y value is negative 1. As we approach it from the right, our y value is 1. In order for the limit to exist, it has to equal the same value, which it doesn't. So the limit on this one does not exist. Going up to 14. Can I plug the 3 in? I can't. Can't plug it in because I get 0 in the denominator. So I have a discontinuity. As I approach 3 from the left, my y value goes down to negative infinity. As I approach from the right, my y value goes to positive infinity. Because those are different values, my limit does not exist. If they had both gone up or both gone down, then you could have said infinity or negative infinity. But they have to approach the same value. Okay, number 15. As x approaches pi over 2. Now, here's pi over 2. As we're approaching along the x-axis, what happens to my y? It goes up to positive infinity. As I approach from the other direction, as I approach from the right, my y value goes down. So, same as the last problem. Positive infinity as we approach from the right, negative infinity as we approach from the left. The limit does not exist. Number 16. As we approach x equals 0 from the left and from the right. As we approach from the left, the value of the function does equal value equals 0. As you approach from the right, the value does exist. It's the same thing. I should have said 1. As you approach 0 from the left, it's 1. As you approach 0 from the right, it's 1. So, the limit of secant x as x equals 0 is 1. Which, if you just plug 0 into secant of 0 is 1. 17 is a weird one that, to be honest with you, almost never comes up. If you take the function cosine 1 over x, as you approach 0, it goes nuts. Like it just oscillates back and forth wildly. And so there's no way to determine as you get 0 what the value is. And because of that, it has no limit. I can tell you, you will almost never see this. And the only circumstance that I can imagine that you'd ever see it is if you had a cosine of 1 over x or a sine of 1 over x. So I would just understand that as you approach from the left and right, you don't get a value, and that's the issue there. Number 18, can I plug it in? The limit of sine of pi of x as x approaches 1 is sine of pi times 1, which is sine of pi. Well, that would be the sine of pi is 1, or pardon me, is 0. So let's look at the graph here. As you approach from the left, the value of the function approaches 0. As you approach from the right, the value of the function approaches 0. So our limit is 0.